All right, guys, so this is the second part. So I'll be doing questions 21 through 40. So 21, which of the following expressions is equivalent to this? All right. Again, this was first quarter stuff, so you probably forgot. To write it as an exponential, you notice how they changed from radical to exponential form? This is what they're doing here. So this was a radical. They changed to exponential form. So you have to know what this means. This number on the outside is your root, and this number on the inside is your power. Okay? And it's always, the formula is always this thing that you have here, that's your base. Okay, so that's the base right there. So if you want to change this to exponential form, the formula is basically base, whatever you have there in the yellow, and then you're going to have fraction bar power over root. Root means, think tree root. So the tree root grows in the ground. So that's always the bottom number. Okay, so that will be the bottom number. So if you use this formula here, based on what I wrote here, your base is what? Your base is going to be n plus 4, right? That's the thing in yellow, right? That's your base. And then when we have the fraction, the root would be 5, and the power is 3. That goes on top, okay? So that's that. So the answer is D. Okay, the answer is D. You could make a mistake and pick C because it's very similar, right? 5 and 3, right? But these two definitely not in the picture. All right, 22. An expression is shown square root. So there's a lot of radical problems coming up here now, right? Which expression is equivalent to the given? There's a couple ways you can do this. You can actually break it down, or you could work backwards if you forget. I'm going to show you both ways. So 80. So you can use the ladder method, which I like to use, or some of you like to use the tree method. Either way, it's all good. And you're using primes, prime numbers are like 2, 3, 5, 7. These are numbers that only divide by itself and 1. Okay, so when you're using the ladder method, you have to use prime numbers when you're dividing. So this is even. I can start with 2. So don't start with 4, because 4 is not prime, right? You have to use these numbers. So 2 into 80 is 40. And I just keep using 2 till I can't use it no more. Right? Just keep using 2. And at some point, this is 5. No, I can't use 2, but I can use 5. 5 goes into 5 one time. Now, once you get to 1 at the bottom, you're done. And then, you're looking for a pair. Since this is square root, you're looking for a pair of the same number. So 2 squared is the same thing. 2 times 2 is the same thing as 2 squared. That's also 2 squared. So I have this, and then I have an odd one out, the 5. All right. So the square root of 80 is now going to become broken down into 2 squared times another 2 squared times this 5. Okay? So you have that 5, and then you have these 2. All right? So I kind of color-coded for you. Now what's going to happen? The square root cancels out this little 2 right here. Okay? Cancels it out. And it cancels out this. So therefore, these are going to come out on the outside. This is going to come out on the outside, and this stays. And when it comes out, it just comes out as 2, plain 2. This also comes out plain 2. This stays. And then whatever you have on the outside, you multiply. So you're going to get 4 times the square root of 5. And the answer is D. Okay? Answer is D. Okay, so moving on to number 23. Again, radicals. So quite a few radicals on this page right here, right? So practice with radicals. The next packet won't have radicals. It'll be something totally different, okay? So an expression is shown, the square root of 108. Select all of the expressions that are equivalent to this. All right. Now, again, select all is like your enemy. That's like the worst question that is going to be on the EOC. So I'm going to show you one way of doing this. All right. We're going to use the calculator to do this one. Okay. We have to check each one of these to see if it's equivalent to that. And what I'm going to do is I'm going to use the calculator, put this in the calculator, get a decimal, okay? And then put all of these in the calculator, get a decimal, and see if they match up. If they match up, then you know it's equivalent. Equivalent means they're the same, okay? They're equal. So this is how we're going to tackle it. Now, again, I showed you in the last video that you should use your calculator in the Google Classroom that I did post a link to. So this is what you want to use for this problem here. Okay, we're going to put in the square root. So the first thing we're going to have to do is figure out what's the square root of 108. Okay, and again, there's no enter sign here, no equals. So this is the decimal, 10.3923. Let me just write down this. All right, let me just write down this. So I'm just going to put this on the side of my paper here. Make a note of it. This is the decimal we're going to be looking for. All right, let me go back. So this works out to be 10.39230.485. Okay, now so this is the decimal. When I work out each one of these here, I need to get this decimal for it to be equivalent. So you see, I'm doing this problem without working out actually, using the ladder here and stuff like that. Okay, so you could have actually done that with this question. If you bump your head and forget how to do all of this stuff, you can figure out the decimal of this and then figure out the decimal of this and match up. You would see that only this one works. Okay, so that's a workaround in case, you bump your head and you totally forget how to do this stuff here. All right, so we're now going to check this one with the calculator. 2 times the square root of 54, 4, right? Good. So let's check that one. We'll go back to my calculator. And where's my calculator? Here. So 2, let me clear this. So I'm going to put 2 square root of 54, and boom. You see that? I'm not getting that 10.39 thing that I have, right? So guess what? That's not going to be, we can safely say this is not part of the answer. Okay, I need to get 10.39 and I was getting 14, right? Good. So let's check this one. Go back to the calculator. So you might be saying, boy, Mr. Williams, this is kind of tedious. Guess what? This is the best way. And you will not have a time issue on the test because you have all day. So 108 raised. So here's my raise button right here. Raised to the 1/2 power. So I'm going to put 1 divided by 2. Boom. Look on that, guys, on the right. What did we get? We got the magic number we're looking for. 10.39, da, 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 da. So guess what? This is equivalent to what we're looking for. So you would be checking off this guy. Good, because we got the same decimal as we got from this. So these are equivalent. 1/2 power, guys, means square root. Okay, so that's another thing. This means the same thing as the square root of 108. Okay, but I'm just doing this calculator thing in case you guys forget that. All right, let's check 9 square root of 12. Okay, so we go back to the calculator. We're going to clear this. Put 9 square root of, what was it? I forgot already. 12, my bad. Square root of 12. So 9 times the square root of 12. Oops, I got to be inside that thing here. Square root of 12. And guess what? That's not the 10 point something I'm looking for. So that is not part of my answer. Okay, so that's a fail. Boom. We're not taking that guy. Then we're going to check this one. Square root of 4 times the square root of 27. All right. So let's do that. As you can see here, you're just making the calculator do all this work, right? So the square root of 4, come out of it, times square root of 27. Boom, that's the magic number we're looking for, guys. 10.39, right? So we know that's equivalent. So we're going to check that. Then we're going to do this one. Now, so it's going to be 3 times the square root of 4 times 3. Okay? So let's do that. Now, we could just multiply these together and we'll get 3 times the square root of 12. We could just put that in the calculator, right? So what was it? 3, let's clear that. 3 times the square root of 12. That's the magic number, guys. 10.39, right? That's equivalent. So we are going to check that one. And then finally, we'll check this last one. So far we have 3 checks. Let's check the last one. But you can see putting this stuff in the online calculator is just way, way easier, you know, than using that physical calculator, right? That they're going to give you. Remember, you will have access to this calculator on the test. So let's put in, and you put it in exactly the way how we see. So we have parentheses 3 that raised, here's the raised button, XY button, to the power of 1/2. So 1/2 means 1 divided by 2. That's what that means. Then I'm going to click down to get down to the bottom. Times 36 raised to the power of 1/2 again. 1 divided by 2. And guess what, guys? That comes out to be 3, which is not the 10 point something we're looking for. So this is not part of our answer. Okay? So the equivalent expressions, the ones where I got this answer all the time, was this one, and this one. So now you can see when you have the radicals, use the calculator, especially the online calculator, to figure out. And then you don't have to do all of this stuff here. So I could do the same thing I just did with question 22. I could have gotten the decimal here, then figure out this decimal, figure out this one, figure out that one. None of these would have worked. But when you put 4 square root of that, these would be the same decimal. Okay, and you just match it up. And then you don't have to be worrying about doing all of this. Okay? Some of you might forget this whole process. So let's do the same thing here for 24. Same thing. All right? So so this is like a workaround, guys. This is like it's not a shortcut because it takes longer, actually, because you have to check each one. But it's something you can do, right? In case you forget the process. So let's figure out the decimal for this here. So I'm going to go back to my online calculator. And we clear this. So anytime, make sure you clear. Click clear to clear your previous transaction, all right? So we're looking for cube root. So cube root, we're going to click this button right here. Okay, click this button. Because this is a square root button right here. But cube root or any root other than square root, you're going to have to use this here. So we click that. And then here, you see how that's flashing? We want to put a little 3 right there. And on the inside, what was it? 72? Let me double check. 72, all right? It was 72, so we put 72 on the inside. And we get this number. So I'm going to make a note. I'm going to write this number on my paper. And that's what you would do. You write that number on your paper. And write the whole thing. Like, you want to match that decimal. So don't round. Don't do any rounding. Write the whole thing. And don't be lazy. I know some of you are some lazy bones. So I'm going to write it here on my paper. And we have 4.16016.764. So this is what I got with the calculator just a while ago. I'm looking for this decimal. One of these things here, because this is multiple choice, one of these, when I put it in the calculator, is going to give me this decimal. So but the only bad thing about this is it's tedious because you have to check each one. So it's kind of tedious, right? So let me check this one first, okay? But like I said, if this was the PSAT, I would not recommend this method because you'd run out of time, okay? So, but since you have time, you can do this, all right? So here we go. Clear this. So we're going to put in 2. And then we're putting in times the cube root. You don't have to press times. You can just click this button here. Boom, right there. Put the 3. Inside is what? 9. And what am I looking for, guys? I'm looking for 4.160. Guess what? My search is over. Thank God. I didn't have to. I got, that's the same decimal I just got. That is the answer, guys. Right there. Boom, done. All right. So I don't have to go any further because since this is multiple choice, it's only one answer that can be right. So there's no need for you to check each answer, like, because this, this one was select all, so I had to check each one, right? But this one, multiple choice, there's only one possible answer, so that's it. You don't have to go any further. You don't have to check this, you don't have to check that, one answer. All right, moving on to the next question, 25. This could be our last radical, I think. Let me check here. Yes, done with radicals, thank God. So how do we do this? Now, this one, I'm not even going to show you. We could put this in the calculator, but guess what, guys? It's way easier. If you see the inside numbers are the same and you're adding them, it's very easy. All you got to do is just add the outside numbers, right? So combine them, add them up, the outside numbers. So -8 plus 4, you can use your calculator. That would give you -4. And then keep this the same, keep. So you put 3 cube root of 7. So you keep these and you add the outside numbers and that's it. So there's no need to, go to the calculator and did what we just did. All right, so that's the answer right there. Now, if you don't remember how to do that, then you'd put this in your calculator, add them up, get a decimal, and then start matching them up like we just previously did. All right, but obviously you can see this is way easier, right? Moving on to 26. So here, now we're done with radicals, thank God. Something different now. Now we're into absolute value mode. All right, so these are, you're going to see these bar problems, these absolute value bars, which we did. I think this is what, maybe third quarter. So absolute value. We're looking at absolute value functions. All right, these questions coming up now is all absolute value functions. All right, so a different theme now, different theme. So again, we have to read. A car dealership wants to sell a used Jeep Wrangler for $32,000. The dealer will allow the price to vary by $1,600. And let me see. All right, let me just jump to the question though. Sometimes you can just, if you don't want to do all of that reading, jump to the final question they're asking. Because sometimes if you do that, maybe you could just answer this question without even reading all that stuff, right? So what is the vertex of the function that? Now, this absolute value function thing is not on the reference sheet. By the way, I forgot to hand out the reference sheet. So next week I'll be handing out this is the reference sheet that they're going to give you on your tests. They're going to give you a paper, scrap paper, yellow, folding paper. That will give you this and a pencil and a calculator. That's it. So you're on your own after that. So here's the one sheet formula. It's just one sheet. There's nothing on the back, just one sheet. Here are all the formulas that we've covered. Quadratics, and the thing is they don't tell you what each one is. Like this is standard form, this is vertex form, this is factored form of a quadratic. This is slope intercept, y equals mx plus b. This is standard form, this is points. But they don't tell you that. That's the thing. We're gonna have to put the names of it here, and you have to start memorizing them. And then this is exponential functions that is coming up as well in the packet. So this is going to be coming up next after absolute value, and then quadratic is recent. And then also we have, So these are the formulas that they never gave before. They never gave any of these formulas, but now you have them. But then there's some with absolute value that they don't. So for instance, absolute value equation looks like this. F of x equals, this is the general form it has. X minus h plus k. This formula is not on the reference sheet. So, all right, this is an absolute value function. And this is what the formula or the form looks like. So the h and the k is your vertex. Your vertex is always h comma k. So in this case here, my h is this right here. And then since there's nothing on the outside, since there's no number on the outside, my k is 0. And my h will be just 32,000. Okay, not negative. So you basically take the opposite of this here to get your h, right? So my h is going to be 32,000. So how you write it, h comes first, you write 32,000, comma, and your k, since there's no number, you put 0. Now, if there was a number like plus 5 on the outside, then you would have 5 right here. So this is the answer, guys. You'd type it in like this because they want you to write it as a point. The vertex is a point, right? So a point has an x coordinate and a y coordinate. Okay, and that's the answer. All right, moving on. Solve the absolute value equations. Write your answers. All right. So this is not bad. So the key thing to solving absolute value equations is to always isolate this. Isolate the absolute value thing, right? So that's the first step. So you want to get rid of this here, minus 45. So the opposite of that is to add 45 to both sides. So you bring that down. And then when you're going to have to subtract here. So that will give you what? 23, right? So now the absolute value of m equals 23. So how you do this, remember, you're going to have two answers for absolute value. You're going to have to split it up. One is going to be this. You're going to get two equations from this. You're going to get m equals 23. So the same thing you have here. Or m, and then you always take the opposite sign of this. You flip the sign, equals negative 23. So you could see your answer like this. Or they're telling you how to write your answer in the computer. So they say, write your answer separated by a comma. So you'd write 23, comma, negative 23. Or you could do, it doesn't matter the order. All right, it doesn't matter the order. So you get that. All right, moving on to 28. So the absolute value equation. So something similar. It's just that they have some drop-down menus, right? So here's the equation, absolute value equation. Why? Because these are absolute value bars. Okay. So let me put it on the side right here and let's solve it out. Very similar to what we just did. All right. It's just a little bit more fussy. So this one is already isolated. Like this is by itself already. Okay, so I don't have to be doing anything. So what you do, since it's isolated, you're going to split it up into two equations. One is going to be x minus 15. Basically, everything you see here without the bars. Everything you see here without the bars. Or the other one is going to be x minus 15 equals, and you take the negative of that. You take the opposite sign. So you don't do nothing to the inside, but you flip the outside right here, right? Opposite. Okay. All right. Then you are going to solve each one. So when you solve each equation, you're going to get two different numbers, two different solutions, right? So to solve this one, we do the opposite of that, add 15 to both sides. We're going to get x equals what here? 62. And then, so that's one answer. And then the other answer, you do the same thing, but you're going to get a different answer because this is negative 47, right? So you're not going to get the same answer. So here, you have to subtract, keep the sign of the bigger number. So when you do that, you get negative 32. Okay, so here's two answers. So what does it say now? Drop down so this is a drop down question. So on your computer, you like click on it and you get two options, right? So drop down tells you how many solutions does this have. So typically absolute values equations have two solutions, typically, but sometimes it can have one, depending, like for instance, if this ends up to be equal to 0, right, then it will be 1. So this has 2, I just got two solutions, right? I just got two solutions here. And then the drop down 2 tells you, well, what are the actual solutions? Like, what are they? Well, it's what we just got here. So obviously what we got here was this here. Good. So it's not that, it's not that, it's not that. Okay. Okay, moving on to 29. Solve the absolute value equation. Write your answer as a decimal. If necessary, round your answers to the nearest thousandths. Now, thousandths we haven't practiced a lot. We've done tenths, we've done hundredth place, but not thousandths. So let's check this out. Okay. Always read the whole question to see if, if there's decimals, they're going to tell you how to round your decimals. Guaranteed. All right. So let's write down our equation. Our equation right here is this guy. So we're going to start by doing that. Take your equation, write it down on your paper. So that's what you do. You write this down on your paper, and then you'd start solving it. Now remember, absolute value equations, you have to get this guy by itself, right, before you split it up. So before you split it up, you notice how I've been splitting up the problem? You do not split it up like here. I split it up immediately because there's nothing around it. This one, I didn't split it up yet. I had to isolate this first, then I split it up. All right, so that's very important. So to isolate this, we have to do the opposite of that. So minus 45 on both sides, right? And then bring that down. We have 7 minus 9y equals, and then guess what? That's 0. Okay, that's 0. So now you can get that sometimes. So this is, when you get a 0 right here, this is going to tell you you're going to get one answer, because this is what normally you do now. Now you'd split it up, right? You'd split it up now, and you have 7 minus 9y. So you don't write the bars when you split it up. You have this equals 0, and then the other one would be, 7 minus 9y equals the opposite sign of that. But negative 0 is still 0. So we really just have one equation. Okay? So we don't need to work this out, because once we get the answer here, there's no need to, work that out. Now, all you have to do is get the y by itself here. So these are just, two-step equations. Why is it 2? Because I have to get rid of two things, the 7 and the negative 9. So that's why it's a two-step. Now, what do you get rid of first, the 7 or the negative 9? Well, at this point in your career, you should realize that this is the last step. This is the division step, right? So get rid of this first. Opposite of 7 is minus 7. Whatever you do to one side, you do to the other side. Subtract, bring that down. 0 minus 7 is negative 7. And then the last step, which you should know again by this time, is the division step, right? Traditional. So we divide by negative 9. This means division, fraction bar. And obviously 9 can't go into 7, so you're going to get a decimal. Now, since they say write your answer as a decimal, normally you would leave your answer as a fraction. So this work, negative over negative, you get 7 over 9. So normally you'd leave your answer as a fraction. But they're telling you write your answer as a decimal. So you need to put this in your calculator, 7 divided by 9. Okay, so let's jump to our calculator. Let's clear this out. So 7, fraction bar means division. So divided by 9, notice how they did put the fraction bar, is 0.77777, all of that stuff, right? So let me go back. And so we got approximately 0.7777, a whole bunch of sevens. Anyway, Now, since you're rounding to the nearest thousand, thousand means 3 numbers behind the decimal. This is the 10th, 100th, 1000th place. Okay, so meaning if they say round to the nearest thousandths, it means 3 decimal places. Because 1,000 has how many zeros, guys? 1,000 has 3 zeros, right? 1, 2, 3, right? So you look on, when you're rounding this, you look on the fourth number, which is this guy. And what's the saying that we've been practicing? The saying is 5 or more, raise the score. 4 or less, let it rest. So this is 5 or more. This is 7, right? So we're going to have to add 7 here. So we have to raise the score. And we get 0.778. Okay? So we're only looking on the fourth number. We don't care about the rest of the numbers behind here. So my y is 0.778. Okay? So read the rounding directions carefully and make sure you do it properly. All right, moving on to the next one, 39, absolute value again. All right, when is this going to end? So you're getting a lot of absolute value practice, guys. Okay, so I'm not going to write down the equation because I'm just going to do it right here. So again, remember, what is the key thing? Isolate the absolute value. Like, get this by itself first before you split. All right, you can't split these up like into two equations until you get this by itself. Okay, so get this by itself. All right, this isolate. Let me put this here. Isolate. Get it by itself. So to get it by itself, we got to get rid of the 6 in the front and the negative 54. Which one do you get rid of first? That's the key question, right? Well, this is the last step. So we're going to get rid of this here by adding 54 to both sides, right? Bring this down. So 6 absolute value, boom, 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 equals 54. Now, don't split this up into 2 until you get rid of the 6. So now I'm working to get rid of this guy, okay? So first I got rid of that, then I get rid of the 6. So how do you get rid of the 6? I'm going to divide by 6. Why divide? Because I'm multiplying here. 6 times this. So the opposite of times is division. So I'm going to divide both sides by 6. Whatever you do to one side, you do to the other. This cancels out, gives you 1, right? And 1 times this is just the same thing, x minus 10. And then what's 54 divided by 6? 9. Now, once you get this by itself, then you split it up into 2 separate equations. And you get 2 answers, right? So one's going to be x minus 10 equals 9, the same exact thing here. Or the other one's going to be x minus 10, same thing, equals opposite of that, negative 9. Good? So make a note. That's the difference right here. One's going to be positive, one's going to be negative. All right. Then this is just, simple, one-step equations right here. So we just have to do what? Add 10 to both sides, opposite, right? You're going to get x equals 19. That's one answer. Add 10 to both sides. And here you subtract. Keep the sign with the bigger number. So those are my 2 answers, guys. 19, positive 19, and positive 1. Okay, these don't work, these don't work, those don't work. 2 answers. All right. 31. All right, so now we have absolute value inequalities. So those were absolute value equations because you had an equal sign, but here now we have absolute value inequalities. All right, so that's different. Okay, that's different. So how do we do absolute value inequalities? You still do the split move. You still try to isolate. The goal is still to isolate this first, and then we split it up. But it's a different kind of split, okay? So I'm going to show you how to do this. What you want to do is get rid of the minus 4 first. So isolate. What's the opposite of that? You add 4 to both sides, right? And then you're going to get, let me put the answer up here, 5x minus 7. And then 14, oh, let me put this sign. This sign, by the way, guys, what is this? Less than or greater than? What is it? Hopefully you're going to tell me less than. First of all, it's pointing to the left. You see like the arrow pointing to the left. So therefore that's less than, left LL. It also looks like a capital L if you bend it, right? So less than 18, right? 14 plus 4 is 18. Then how you rewrite this is, if it's like this, if it's less than, this is going to be an AND inequality. There's two types of inequalities. And this is going to be an AND compound inequality. There's an AND and then there's an OR. Okay? All right, so I probably have to write this better here. Let me try to rewrite this better. Inequality. All right, so when that's an AND, what we're gonna do, how you rewrite it, just look very carefully now. You're gonna take the opposite of this number, put it in the front. So you take the opposite of that, put it in the front, then you keep this sign here, so less than. Then you're gonna put this here in the middle, 5x minus 7, and then you're gonna keep the same exact thing here, what you have right here. Okay, so. And then now you solve this because you're trying to get x by itself. You're trying to get x by itself, okay? So here's how you solve it. So this, we've done this before. It's just been a while, all right? So we're trying to get x by itself. We got to get rid of the 5 and the negative 7. So this is the last step. You know, the variable is the last step, right? So we have to add 7 here and then add 7 everywhere on the side, in the middle and the side. So add 7 on the side, in the middle, and a 7 on the end right here. Good, so 3 different places. This cancels out. Let's do the math right here. We're gonna get what here? Negative 11. So negative 11, I'm running out of space here. I'm gonna get 5x in the middle, and then this is gonna give you what? 25. Good? Then now I have to get rid of this 5 to get x by itself. So how do we get rid of this 5? Remember, there's always 4 choices in front of you. There's a add, subtract, multiply, divide, right? So what do I do here? I divide because we're multiplying here. So you take the opposite of multiplication is division. So we divide by 5. Fraction bar means divide. And then you put a fraction bar everywhere. Good? Now, you see why they say round your answer as your decimal answer to the nearest tenth. So you have to be very cognizant of what you're doing here, right? You have to, read. This is to the nearest tenth. So we're going to put this in the calculator because this is going to give you a decimal. This is a whole number. This is going to be a whole number, but this is going to be a decimal, all right? So you have to be cognizant. So we have x, bring down this, become x. And then we're going to put this in the calculator, jump to the calculator, clear it. So we had negative 11 divided by, 5? And it gives you negative 2.2. Now, guess what? That's already to the nearest tenth. So, you lucked out. You don't have to do any rounding, right? No rounding whatsoever. It's just going to be negative 2.2, all right? So, you keep your answer like that, so negative 2.2. And then this one is just 25 divided by 5 is 5. So that is your answer, guys. This is what you type in, just like that. Okay, you type your answer in just like this. You're good to go. All right, 32. Got a few more, and then we're going to wrap it up here. I'm going to 40. Which of the following is the graph of the solution? All right, so more absolute value inequalities. Okay. Now, the key thing here, notice here, this one was pointing in, all right, like this way. This is going to be an AND problem. This one is pointing out to the number. So this will be a OR. This is going to be a OR compound inequality. And what's the difference between OR and AND? Well, the graph, for one, the way how you split it, right? And the graph is going to be like split. One is going to go that way and the other one's going to go that way. And if we were to graph this guy, if we were to graph this will be connected. The graph will be connected. Okay? So let me write down this problem right here to get some space. All right, so I'm going to rewrite this problem here. 4x minus 12 is greater than 24. So how you write this now? You're going to write this the same way. 4x minus 12 is greater than 24, or, you're using the word or, right? Running out of space here. I need some more space here, so let me put it over here. 4x minus 12 is greater than 24, or 4x minus 12, and then you flip this sign. So you flip it, and you put the negative of this. You put the opposite sign, negative 24. Okay? Still running out of space. What's going on here? Oh, my God. So, 0... I have to decrease my font size, guys. All right, flip this sign, and then put the opposite sign. Okay, so you see, make a note of what happened with the second one. This is the difference right here. This versus the other one, I didn't do anything. I just kept it the same. But the second one, I flipped this and I changed the sign. Then you solve each one separately, and you look for the graph. All right, good. So here, so we're going to basically have two different inequalities going on here. So I have to add 12 to both sides. You get 4x is greater than 36. Then you divide by 4. You get x is greater than 9. So this is 1, This is one inequality. Then you do the same thing here. Add 12, add 12. The difference is, when you add these, here you have to subtract, right? Keep the sign of the bigger number, you get negative 12. You divide by 4, you're going to get x is less than negative 3. So that's my solutions. So this is saying x is greater than 9 or x is less than negative 3. Okay, so guess what? Looks like it's going to be this one, guys. This is the graph right here. It's split. You see how it's split? So this is here. This part is going, x is greater than 9. So here, this is 9. Notice the open circle. Open circle means, let's say, for instance, if this was underneath here, like an equal sign, you would shade in this circle. Okay, but that's not there. Okay, so let me take that out. All right, so this here represents this part of the graph, and x is less than negative 3 represents this part of the graph. So I don't have to go any further. I don't have to look any further, guys. This one here, you notice how it's, I don't know if you see it properly. There we go. Let me zoom in. So here, this is split, okay? And this one is connected. So you don't want to pick this one. Connected, when it's an or, do not pick any connected ones. So if you have to guess, it would be between this one and this one. And it's not this one for sure. Okay. All right. What's the difference with this one? You notice how it's shaded in? That would be if you had some equal signs underneath here, then you'd be picking this one. You'd be picking this graph. Okay. So shaded circles means if you have the equal sign underneath there. All right. So just try to remember that. All right. So, but the answer was A. Okay, moving on to 33. So we're done with absolute value now. Now we're going to get into exponential. So we're getting into exponential functions. Now, the good news is, guys, is that these formulas are on your reference sheet. Okay, so let me flip over to the reference sheet here. Boom, right here. We do have exponential formulas right here. So we're going to be using this a lot, and also this one for the questions coming up. Okay, we're going to be using these two formulas. Then there's also some compound interest formulas as well. So thank God they gave you this one, because this is right. So thank God. All right, moving on. So the number of grams in a sample of a radioactive substance after X years is shown in a table. Okay, so this is the grams, and this is the amount. Okay, so all right, let me write it here. Grams. This is the amount after X amount of years. So, read the problem, guys, write stuff down, and, you know, figure out what's happening. All right. Which statements are true about the sample? Select all. Okay, here's our friend. Select all that apply. So to select all means you have to check each option. There is no lazy bones about this here. All right. So the sample is growing. Okay, let's see what's happening here. Is X increasing? Let's see. Is X increasing? Is X going up each time? Yeah, X is going up by +1 each time. So as X is increasing, is Y increasing? Well, let's look. Y is 2,000 and it went down. So this went down by a certain amount. This is going down. Okay. So if it's going down, obviously it's not growing. The sample is not growing. Good. So I started off with a certain amount, and as it goes up, this is going down. All right. So this will be decaying. All right. This is decaying. So that answers this question. The sample is it's either two things is going to happen with exponential. Either it's growing or it's decaying. Those are your two options, right? So how do you know which one? You look on your Y, not your X's. You look on your Y, okay? Because if you look on your X's, you think, oh, X is getting bigger, so you're picking that one. So to determine that, you look on your Y values. Okay, your Y is decreasing in this example here. So decreasing means decaying, right? Decreasing. So the sample grows to 5,880. So this is the sample amount. Y is the sample amount. So after 3 years. Okay, now is that true? Well, after 3 years, sorry, my bad. Did I put grams here for X? It says X years. So totally messed up there. This should be years. All right. X is years. So yeah, I'm not even reading properly, right? I just read grams here and I said, oh, X is grams. Please forgive me. Anyway, so X is, we have X years, right? So look, check that out. After 3 years, so let's look at 3. Here's 3 years. The amount is what? 91.875. And they're saying the sample grew to that amount. So we know it's not growing, so don't pick that one. Okay? Now, let's check this here. The initial amount of the sample is 735 grams. So look for that number, 735 grams. And what do we have here? Year 0, which is the initial amount, right? Your initial amount is always when is the beginning, when you started. And when you're beginning, it's 0 years, right? No time has passed, right? So that's always when X is equal to 0. So this is actually true. This is actually true, all right? The sample decays to 91.875 after 3 years. So let's go back to the 3 years, check that out. And that's true. After 3 years, the sample amount is 91.875. So that also checks out. So we have 3 checks. Now, don't be thinking that it's always 3 checks when we have a select all. It could be 1 check. It could be 2. It could be none. Well, no, I guess. No, it won't be none. It's always going to be at least 1, because if it's none, that means you could like guess and, you know, well, who knows? All right. So 34, moving on. Again, this is all exponential function stuff. How do I know it's exponential functions, guys? How do I know? Not because I'm a math teacher, because I look at this here. You see how the exponent is a variable? If you have a variable exponent, that means you have an exponential exponent function. Okay? So that's how I know, just by looking on the function. This exponent is a variable, so that makes this an exponential function. All right, and also look, this looks similar to what? It looks similar to this, right? Under the exponential function rule thing, right? Good. So here what we do now. So let's read this. The growth of a sample of bacteria can be modeled by the function that, where B is the number of bacteria, so B for bacteria, so that's why they call the function B. And T is time. So anytime you see T, typically means time, right? What is the number of total bacteria after 3 hours? round, here we go, round to the nearest whole number. Okay, so you got some rounding directions. So this is easy. You know why? Because this is straight up calculator problem, right? So we're basically finding b of 3 because time. So we're going to put a 3 here in this spot, and we're going to put a 3 here in the t spot. So we're going to find b of 3 equals 100 parentheses 1 plus 0.6, and then your t means time. How many times after 3 hours? You put 3 right here. Now your answer is just this here that you're going to work out. This is what you put in your calculator, not this. Don't put this in the calculator. This is what you put in the calculator. Okay, so let me write that down real quickly because I'm going to switch over to my calculator. And my young brain is not going to remember all that stuff right there. Okay, I wrote it down, switched over, boom, clear this, clear. And I'm going to write down what I had here, 100. You write down exactly the way how you see it. Parentheses, 1 plus, what's this, 0.6. You don't have to put the 0 in front. You can if you want. Parentheses. And then now I need raised button. So that's my XY button right here. Okay, click that to the what power? 3. Boom. What's this here? 409.6. All right, 409.6. So that's what we're gonna, now it says, oh, okay, good. 409.6. I love this. So guess what now, guys? If you put 409.6, you just got this wrong. Why? Because the thing told you to round. And I know a lot of you don't like to read. That's the problem. Young people don't like to read anymore. So round to the nearest whole number. This is wrong. Whole number means I don't need a decimal point. I just need the whole number part. Okay? So very important that you round and read the problem. So we look on here. This is the number that you use to determine how to round, right? So if it's 5 or more, you raise the score. This is 6. So I'm going to raise the score. I'm going to add 1 to 9, and I get 10. So this works out to be 410. That's to the nearest whole number. So it's a 410 bacteria. So after 3 hours, that's how much it grows. Okay? And guess what? They could ask you, what is the initial amount? They could ask you at the beginning, before, when time equals 0, what is the initial amount? What would be the answer for that, guys? If they ask you that, they say, what is the initial amount of bacteria before the experiment started? What would it be? It'll be this number here. This outside number. That's your initial amount. Okay, so remember that. Okay, so in the beginning, there was 100 bacteria. After 3 hours, this is exponential growth because it's growing. It will become 410 bacteria. So it's growing very fast, and after 5, 6, and so it's even faster. All right, moving on. 35. Again, this is exponential functions. How do I know? Here's how I know, guys. I'm going to read it. A table of values for an exponential function. That's how I know. I read it. I read the directions. Okay, so you have to read. Anyway, what's happening here? Look on your y values. So they don't give you anything other than that. They just give you a table. All right. Look on your y values now, guys. Is your y going up as I, move along the table here? Yeah, it's going up, right? So it's increasing. All right. So if it's increasing, that means it's what? It's exponential growth. If your y is increasing, that means exponential growth. There's only 2 options. You either have growth or decay. All right. So is your y going up? So y goes up. It's increasing. You have exponential growth. All right. So not decay. So let's check out it says, which of the following statements is true? So this is multiple choice. It's not select all. Let's read. The table of values represents an exponential growth. So, all right, that's true. Because as x increases, so here, as x increases, it's actually going up by 1. As x increases, right? The y values increase at a constant percent rate. And that's true, okay? That is true. So, boom. We don't have to go any further, guys. This is it. This is our guy right here. That's the answer. So if it's multiple choice and you read the first option and it's correct, and you know it's correct, like hopefully you realize it is the correct answer, then there's no need to go any further. All right. 36, more exponential growth. How do I know? Because this is what exponential growth and decay looks like. Actually, this is decay. This is actually decay. Okay. Because as x is increasing, y is decreasing. So this is actually exponential decay. These are good things to know, guys. All right. Even though they're not asking you that. All right. What are they asking you? Based on the graph, what is the original temperature in degrees Fahrenheit of a cup of hot water? So original means what you're starting off with. The original means the initial, the beginning. I don't know how many ways to explain it, right? So in the beginning mean what? Time is equal to 0, right? Time is equal to 0. I haven't started yet, right? I haven't started whatever I'm doing, right? So 0. So when time is equal to 0, look in your graph here, boom, right here. When time equal to 0, the temperature of the water in Fahrenheit is 100. That's it. Easy question, guys. Using your two eyeballs and checking it out, okay? So 36. Let's see. Moving on. We're getting closer to 40, guys. I'm getting tired right now. So $1,000 is deposited. All right, look on this now, guys. You see this function right here? Very similar to this. And you will have this formula sheet with you. They will give it to you when you enter that exam room. So you want to use this formula sheet and for certain questions. So you see, it's very similar. So it's an exponential function. How do I know? They even tell you in the problem. Okay. So let's read it. $1,000 is deposited in a saving account with interest compounded annually. Boom. All right. This is compound interest. This is compound interest. Let me go back to this here. So this is actually boom. All right. Now this, it depends. This formula you use. All right. Let's go back. All right. So what do we have here? What is the value of R rounded to the nearest hundredth? All right, rounded to the nearest hundredth. So let me highlight these key things right here. Round to the nearest hundredth, all right? So please read, guys, because if you don't read, you don't know what they're asking you to do, okay? You'll just be on your own doing your own thing, all right? So what do we have here? Let me write down the equation, what I have, all right? So the $1,000 right here represents the beginning amount. So you see this number on the outside? This is your A value. This is what you started off with in the bank. You put $1,000 in the saving account. That's your beginning initial amount. All right. Now it says after 1 year, the account went up to 1,020. So you can see it in the table. After 2 years, it went up to this amount. Okay. So this scenario can be represented by that. Okay. What is the value of R? Okay. So there's a couple ways you can do this. Let's write down the function. Always write. If you don't know how to start the problem, just write down the function. Like just do that. Write it down, and then take a good look and see what's happening. We have to solve for R. All right. We have to solve for R. So there's a couple ways we can do it. We can say, all right, after 1 year, what do we know? After when X is 1, Y is going to be what? This amount. Now, what does f of x mean, guys? Anybody remember? This is what I'll be asking in class. I would say, okay, what does f of x mean? And then some of you would say, y, Mr. Williams. So you put y. Yeah, f of x is y. So let's write y instead of f of x, right? So f of x is y, right? So let's put that to remind ourselves. This is just a fancy way of saying y. All right, so don't be scared of that f of x thing. So 1 plus r. So now I'm going to use one of these points. Why did I pick this one? I don't know. It's probably easier, right? But you could have used this point. You could have used this point, any of these points, and plug it into here because we're going to try and solve for R. That's what they're asking you to, right? So I'm going to use this point, and somebody else could have used this point and still get the same R, all right? So y is 1020, I'm using this point right here, equals 1000, then I put the 1, then I put the R because I don't know that, and then I put the X, which I do know, which is 1, okay? And then I just solve that for R, okay? So how do I solve this for R? So the first thing you probably want to do, see I'm working on this side here. The first thing you want to do is probably get rid of the 1000 first, right? Get rid of the 1000. So since you're multiplying here, you're going to divide both sides by 1000. Okay, you're going to divide both sides by 1000. When you divide this by 1000, I'll just move the decimal point. You know, this is going to become 1.020. And then I'm going to have R1 plus R to the first power, which is just the first, it's just 1 plus R. So I'm going to just put 1 plus R. I don't need the parentheses. And then I'm just going to subtract 1 from both sides. So subtract 1 from both sides. And when you subtract 1, you're going to get 0.020 equals R. Okay? And it did say round to the nearest tenth, 100. So if you put this answer that you just got here, you actually got it wrong. You did all this work for nothing because this would be to the nearest 1000. 100 means it has 100 has 2 zeros. So you mean you need 2 numbers behind the decimal point. So guess what? You chop this off. You don't need this extra 0. Okay? So this would be the answer. Don't put that extra 0 there because you get it wrong. So make sure you read the rounding directions. Very important. Okay, very, very important. All right, moving on to 38. 38, again, is an exponential function. How do I know? Because you have x as the exponent. Okay? Now, and remember, f of x means y. So if you want, you could just change that to y immediately. Okay? So I'm going to have y equals -4, parentheses 1 plus 1/4. So 1/4, 1/8. Yeah, it's time to knock it off now, guys. I'm getting tired. So what am I doing now? So what is the sum of the y-intercept? Oh, all right, this is complicated. What is the sum? Sum means to add up. So we have to find two things here. We have to find the y-intercept. When we find that, we have to add it. We have to add that here, the y-intercept, to the value of when x is equal to 1. All right, so this is a little, you have to, kind of read this very carefully. All right, so we need to get two answers, and then when we get it, we have to add them up. Okay, we have to add them up. So the first thing you have to find is you have to find the y-intercept. How do you find the y-intercept? Well, you find the y-intercept by letting x equal to 0. Because, on the y-axis, x is always equal to 0. So if you put a 0 here, for x, guess what? This became very easy because anything to the 0 power, guys, do you remember your rules of exponents? Anything to the 0 power is always not 0. I know some of you are going to tell me 0, 1. All right, so this is first quarter stuff. Anything to the 0 power is 1. So I'm going to have -4, and then all of this here works out to be just 1 times 1 equals -4. So the y-intercept is -4. Okay, that's the y-intercept. Y equals 4. Okay, so we got that part, and then now we have to find the value of this when x is 1. So that's more work here now. Okay, so where should I put this here? Well, let me just put it underneath here. So I'm going to put y equals -4, 1 plus 1/8. So when x is 1, I have to put in, this is the x part right here. So I have to replace this x with 1. All right. So I'm going to put 1 right here. And then guess what, guys? This is now, me personally, I am going to jump to my handy dandy calculator, the online calculator, and put all of this stuff in to get my answer. Okay, I'm not doing this by my the calculator they give you to hold, the black one, right? I'm not doing that one. So let me write this down on a paper so I can remember what to type in here. Okay, and then anything to the first power, guys, is just the same thing right here. So anyway, so here we go. Jump to the calculator. It's right here. Let's clear it. Always clear it. Always clear out the calculator. So I had, this is what I'm entering. -4, parentheses, 1 plus, where's my plus? All right, plus, and then I have 1/8. So that means 1 divided by 8. Where is it? 8. Okay, and then parentheses. Now, so no, it's not what I want here. Boom, take that on. So I put here, and parentheses. Yeah, okay. Now you don't have to put raised to the first power. You don't have to put that, guys. All right, I'm gonna even show you it doesn't make a difference because anything to the first power is the same. So if I put raised to the first power, guess what? The answer is still -4.5. Good. So no need to put that. But if you do, you can see the answer did not change, right? All right, so -4.5. So that worked out to be -4.5. So all with the calculator, guys. See, you wouldn't, I know most of you would say, oh, okay, I'm not working this out. It has a fraction. I'm not doing it, right? So now that is the hardest part, but you have to remember what they asked you to do. They asked you to sum up. Sum means to add up. So you're going to add your y-intercept, which was what? 4, -4, and add it to the value when x is 1, which is -4.5. So basically, this becomes -4 plus -4.5, right? And if you put that in your calculator, you should get the right answer. So let's go back and put that in the calculator. So what was it? Clear. It was -4 plus, and if you want to use parentheses, -4.5 parentheses, guess what? -8.5. So even if you don't know how to do this with your brain, some people could do this without the calculator. Use the calculator to get the right answer, right? -8.5. And that is the answer, -8.5. Boom. All right. Couple more questions. I'm done, guys. I'm getting tired. So given the table of values for the function f of x, answer the following questions. All right. What is the equation for f of x? So now you have to figure out what type of equation is this. Is this linear? Is this quadratic? Is this exponential? And how you do this, you have to look and see figure out what is the trend here. What's going on, right? So your x's. Is your x's going up? Okay, your x's are increasing. Is it going up by a constant amount? Yes, I'm going up by a constant amount. Okay, all the time. Okay, good. Now, then you look on your y's. Well, is your y increasing? Yeah, the y is increasing. By how much? Well, it went from 3 to 12. So if you subtract, this would be what? 9. And then if you subtract here, this is going, all right. So it's not going up by a constant amount. You're not adding a constant amount. But try dividing. So if you divide 12 by 3, you get what? 4. And if you divide 48 by 12, you get 4. So it looks like you're multiplying by 4 every time. This is what's happening. You're multiplying by 4. So therefore, this is going up by a constant amount by multiplying by 4. So this is actually an exponential growth function. All right, it's growth. And how do you write that? Well, you're going to use your formula sheet and use this here. You're going to use this. We did a lot of this in class as well. I think this was maybe third quarter, all right? So f of x equals a times bx, right? So you're gonna use that formula. F of x equals a times bx, right? Is that what we had here? Right? Yep. Okay. So what is my a in the problem? Well, my a is gonna be 3, because your a is always your initial amount. You're starting. So your a is always the initial amount. All right. And let me write this here properly. And my b is the multiplication effect. All right. The multiplication growth factor. That's what they call it. All right. I don't know if you're going to remember that. So here we go. So my a is my initial amount. Okay. And my b, let me label this, is what you my b is this guy. This is my b. How much am I multiplying this by all the time? Constant. So I'm constantly multiplying by 4 from the previous answer. So my b in this problem is 4. Okay, so my b is equal to 4, and my a is equal to when x equals 0. All right, when x equals 0. So which is this guy. So when x equals 0, that's the beginning amount. I started off at 3, okay? So you'd put 3, and then you could put times 4 to the x power. That's it. Put it like that. Or you could put it as f of x equals 3 parentheses 4 to the x power. You could put it like that too. Either one. It's the same answer. All right? All right, moving on to 40 now. One more here. Whew, it's been a lot. So, all right, so here we go. The value of an art piece since 2010 is modeled by the function, and again, still exponential form because you see the x is an exponent, right? Complete the statement. The value of the art piece in 2010 is drop down 1. So what is the value of the art piece in the beginning? Because that's where we start in 2010. So the value is going to be this number. The initial value is this here. Okay? So that front number is your initial value, right? So that's the price of the art piece in 2010. All right, so that's easy. And it increases or decreases in value. So is it increasing or decreasing? And so this is where you have to look on this number. You have to look on this inside number here. If this number is 1 point something, all right, it's always going to be increasing. So increasing. Because it's 1 point something. If this number was less than 1, so like 0.48 or 0 point something, anything 0 point something, then it would be decreasing. So in this case here, it's increasing. So boom, increasing. All right, based on this number right here. It's based on this number. All right, and then the final one is the value of the art piece in in value by a rate of every year. So how do we get that? Now the rate is going to be 12%. So how do I get that? How did I get that? You look on this number right here behind the decimal point. So 0.12, if you change that to a decimal, you have to multiply, change to a decimal. How do you change a percent to a decimal? Change to percent. What do you do, guys? Anybody remember? You have to multiply by 100. And you end up getting 1. You move the decimal point 2 places to the right, you get 12, and then you put a percent sign. Okay, so that's it. But you're looking on this number right here on the back, right? The 0.12 to get that amount. And that's that. All right, guys. So we got up to 40. So I'm going to end this video right now.